Hello and welcome to another C tutorial video. In this one we will cover the pointers in C. Many starters or beginners in C struggle to understand how pointers actually work, and by watching this video you will have an idea how to use them, how to apply them in the right manner, so that you do not get any exceptions or so that your program does not crash. So before we start coding, I want to introduce a specific structure, and that structure I want to illustrate in Photoshop. When we deal with variables or parameters, I want you to imagine them as either as a box or shell, and within that shell we have a value, right? Value and shell. So any variable has this structure. So for instance, if we declare an integer and initialize it with 100, then this variable foo has a shell which is constructed by the compiler, and within that shell we have a certain value, and that value is 10. In C terms, this shell is the address, and the 10 is the value. So you might have heard already the phrase everything in C is copied by value. That's a true statement, and we will see in a second how that actually translates to code. So for instance, we can like apply this for any data type. If we have, for instance, char, let's say char C is C, then we have this shell for this variable C, the address, and we have a value within it, right? This char. The same applies to double, to float, let's say 0.0, here again. And when we deal with addresses like pointer to integer, foo, then we have this shell for foo that's untouchable. We get that through the compiler, untouchable. And within that, so the value of foo would be another shell, because we deal with addresses, right? And then we have the integer. And for illustration purposes, I will stick with the value 5. So this outer shell belongs to foo, and this inner shell is the value of foo, which is the address, which is an address, right? And it points to an integer. So what happens when we declare functions? Let's say void foo int a. A is a parameter. The compiler constructs a stack frame, and within that stack frame there it holds this variable or this parameter. It gets its own shell, and within that shell it has a value. If it has an argument, then the value is copied. Like if we have, like, for instance, if we call foo with that is a 0, right? foo with 5, then the value 5 is copied here. And if we pass, for instance, like if we have integer bar with the value 100 and we call foo with bar, what happens? Well, bar has its shell, and within that shell it has the value 100, and by passing bar as an argument, 100 is copied here into this. So that's copy by value. You know that in C we have also the ampersand symbol, which is quite often used. So what does it do? It actually returns as the address of a variable. For instance, if we have int foo and we initialize it with the value 10, and then we have integer star bar, so a pointer to an address, right? We have an address and point to an integer. We pass, now we want to point to foo, so what do? We pass the address of foo. What happens? Foo has its shell. Within that shell it has 10. Bar has its shell. It holds an address, another shell. And within that shell, okay, it's undefined, but we stick with 5, right? And then what happens here at this assignment, we change what is inside. So we change the value, we change this. And what do we assign here? We assign this one here. So bar turns into this. That's very important. Okay, so we could now, I can show you now an example in Visual Studio. Let's say we have integer foo, which is 10. We can now print the address. I will also show you how to print the address. We use %p and then line break, and then we use the ampersand foo. And then we have a pointer bar which gets the address of foo. And now we print the value. Okay, now let's see, address of foo, and here we have the value of foo. Two different things. So let's see. Okay, as we can see, the value of foo, the value of bar. So again, the value of bar is the same as the address of foo, since we assigned it, right? And however, if we would now print the address of bar, that would be something else. So ampersand address of foo ends on 94. Address of bar is B8, something different, but the value of bar is 94. So address of foo is the value of bar. Okay, so we can now, I want to give you a specific example where like grasping this idea is very crucial. For instance, you want to allocate memory outside of the scope. You have like two options. The first option would be something like this. As a return type, we allocate memory via return. Okay, we get here the size and we return what we have. So we return the value which is returned via malloc. And now we can use that. We could say, okay, let's say var allocate memory via return, just a single integer. Okay, that's it. That's a very small example and a very easy one. We can again work with our illustration. So what actually, when we call malloc, what happens here? So we pass here the size. What happens here is malloc just returns a value. That's very important to understand. It's important what we do with that value. We assign it to a variable, right? Or return it. So when we assign it to a variable, foo, and call malloc, what happens, foo has its shell, again untouchable. What happens is the value which is returned through malloc, it's an address to an integer, right? In our case, with sticking to our example 5, we assign the value to foo. So this happens by this assignment. The same goes for return types. For instance, if we return a pointer to let's say allocated via return malloc, and we have here an integer bar, we call foo semicolon, right? What happens here, bar has its shell and we assign a value, so something for this part here. And we have also like the possibility, for instance, we have an integer star bar 2. Bar 2 has this shell and it holds an address, and here we have 5, for instance. Okay, we have the possibility through using the ampersand, we can pass this address as an argument, for instance, or in assignments. We can pass that by using the ampersand bar 2. So that's now very important for the sophisticated example in allocating memory. So we allocated in our first example via this return type. However, the sophisticated one would be, there might be use cases for this, allocate memory for argument. Now in size. So the first argument, it's important what do we pass here. And again here, allocate memory for argument. We will pass like the size, and here we can complete at least this one here, size. Okay, we need an assignment, right? But what do we place on the left hand side? The left hand side would be like the argument, right? So at this point we can move again to our canvas. I want to illustrate you this example. So let's say we have our main function, right? Int main void. Here we have a pointer foo, and we want to call the allocate memory for argument. Let's abbreviate it. Yes, okay. And now we need to pass an argument. Here we have then the size. Okay, we will call this MA. So here, let's say we have here size of integer, right? the second argument. So what will be the first argument? That's very important. So we want to allocate memory for the argument. So the argument, what do we need to pass here? If we again recall, foo has its shell, its address, and it has a value, which is like an address, and it points to something, right? To, for instance, 5. In this case, we could say, okay, it's now then we would have now then this whole thing points to null. And here we have something which is not defined, okay? So, at this point, it's important, okay? We know, okay, we have foo, and we want to allocate memory for foo. So what does that mean? We want to have an address for which the operating system reserved us or allocated for us, right? So we want to change for foo its value. So we want to change actually this one here for this here, for this shell here. So this function here needs to know this shell here. If we pass, for instance, int point a has its own shell. We draw this every time. Each time we draw this. That's here. So it's a pointer address to something like 5. Okay. So if we then if we were to like do something like this, what would we do? We would do the following. Let's say we passed here foo. So the type matches, right? It expects pointer to integer, foo is pointer to integer, we pass foo. What happens here? Here happens the following. This one here, its value, it is copied. So this red here, box here, shell here is copied. So to which place is it copied? Well, we had here A, right? A has its shell, it's copied to this place here. So if we were to like, it's copied here. So what is happening when we do then something like this? Well, we assign something new as a value for A. That means we change this. We change this. So it does not hold this anymore through the assignment. Then it's something different. And it might point to like a place with 10 integers, which can hold 10 integers or 100 or whatever. And let's say single integer with the value 10, for instance. Right, okay, we allocated memory for A. Because A has its shell, we changed, like malloc returned an address. This is the new address, and we operate on this. And however, we lose something very important. What happened to the address of foo, right? We want to allocate actually for foo. So at this point we see, okay, this does not help us. This is not the right type. We need something else. We need something else. And the right thing, we will see it in a second. The right thing is int, let's say in red, int star A. What does that mean? We have for A its shell, it's there. We have an address shell, the first star, the second star, and then we have the integer, right? Let's say 5. So when we say then malloc, when we do this, a malloc, this would overwrite this one. We would change the value of a, what's there. However, we don't want to do that. We want this to be the address of foo. This should be foo, and we want to change the address which it so we want to change its value. So we want to allocate and override its value. So we then don't assign anything to a, but we say star a. Star a means, okay, we access its inner shell, so we access its value, right? And here we say for this shell here we allocate memory, so we get this orange new shell here, and via applying it in this way we can allocate memory for our parameter, and in this case for our argument. So a last step is missing. What do we pass here? We need a pointer to an integer. Again, what does that mean? It expects us to pass a value which is a shell, an address, which points to another address, and then we have like our integer. We need to pass something like of this shape. Our foo has its own shell, right? It is a pointer to an integer, so an address, and then we have like this. So that's the structure of foo. If we were to pass foo, then we would pass its value. So what's the value? Well, the value is just this, right? However, if we look again, what does A expect? A expects this, right? So we need to pass this whole thing here. And as you recall, we can do that by using the ampersand. So we pass the address of foo. So we pass this structure here. What happens? A has its shell. It requires this as a value, so it matches. And what do we do then? Okay, we via star A, we access A's value, so this blue box here, and for that we assign a new address. For a new address, so we change this one here. We allocate it, and outside of this scope here, outside of this function scope here, foo has its new address or its new space. So we can do something like this. So let's see this in action. We pass here our pointer to pointer. Let's say I need memory. Okay. Then I need memory, malloc, perfect. Now let's pass here, let's say foo. We pass the address of foo, and let's print some addresses. in order to see how it works. So we did this here. Now we can address of I need memory. So the address of I need memory. Perfect. Then we print the value of I need memory. That would be this here. And let's say we were to assign a value, let's say 100. Let's say value of star I need memory is again an address. And finally, we can print the value. This is an address. This is an address. And okay, and let's also make some printing here. Let's say we were to print the address of foo. Now we can print here the value of foo, which is an address. And finally we can print what's stored in it. So value of, that's indicated value of this one, right? Okay, let's print and see the result. So the first printing, the address of foo is 78. So this is foo's shell. So that's it. That's untouchable. We keep it that way, and it's important now when we pass it as an argument to allocate memory for argument. So we pass this address here, right? Then within this allocate memory for argument, the address of I need memory is something else. So it's created through the compiler. It has its own address. Okay, what's important is as we access like I need memory, its value, it holds an address, right? The address it holds is the address of foo. And when we access it and allocate memory, we then get this newly allocated memory, 440, right? And when we print the value of foo is an address, right? Pointer to an integer. We print the value of foo, it's an address. It's the newly allocated memory, 440. And here it was like the value of this one here. And when we assign something to this address, like the value 100 here, we can print that it's 100. And outside of the scope, since it was allocated and we assigned a certain value, and outside of the scope, we still see this value. It's here. So it's kind of like it helps a lot when you think it by means of boxes or shell which holds a value and which is passed to functions. It helps a lot if you can imagine how this like behaves in a structural way. it's really, for starters and beginners, it can be frustrating to work with pointers. You get lost so easily in the process of understanding it, because it's the way how this language was designed. So it's very important to not forget any variable has its own shell and it's untouchable. And you can pass add the address of this shell by using the ampersand, and by doing that you can do lots of fancy stuff. And like in our case, we allocated memory for the argument, and that's quite like useful, and you might find also other use cases. So I do not want to cover more on this regard. I hope that this will help you to understand how pointers actually work, and I hope to see you also the next time in my next videos. So stay tuned and see you until the next time. Bye.